So, yeah, I'm Bearded Foo. I work at Container Solutions. We're a cloud-native consulting company in Amsterdam. We deal with containers and Kubernetes and things like that. And we sort of also pay attention to upcoming technology, which serverless is one of those right now. So serverless isn't really like at the core of what we do, but then it's not at the core at what most people are doing. So it's hard to consult for it. Yeah, so one sort of big question that I think a lot of people have is what is serverless? Because obviously they're still servers, and so it's arguably kind of badly named. And basically serverless is about like reducing the size of the deployable unit of a program. So if you look back like 30 years ago, the deployable unit was the whole program. You couldn't deploy any less than that. And actually, at the time, you kind of couldn't deploy your dependency libraries either, because probably it was so big that if you changed your dependencies with every deployment, it didn't really work. So then we moved to more of like a deployable unit as being individual libraries, and then the program with all of its dependencies kind of packaged together like a Docker type thing. And serverless is now about reducing it to where you can just deploy a function. So if you have to update 2 functions to fix a bug, that's 2 tiny deployments. It's not a rebuild and then a deployment of some big, massive system. So it's in a way, it's a little bit of a departure from kind of recent pushes to sort of bring all the libraries and dependencies in with the deployable unit. And then from a financial perspective, it's also about really trying to understand kind of charging the customer by the functions that get called, not by the programs get called or the servers hosting them. So it's also about changing kind of the smallest financial unit in computing as well, which that probably has arguably like some more kind of serious ramifications in the industry than the technology perspective of it. Because there's going to become a day now where your CFO can look and see how much the function you wrote is costing, which is maybe good and maybe kind of scary also. Yeah, and so it's scary and it's very different from what people have done. But then in some ways, in terms of like how it's implemented, it's actually not so different from the way container hosting is done. It's more so just building. In a way, you're sort of building containers with a lot less on them, although often indirectly you're no longer writing Docker files, usually if you're the consumer of a serverless framework. So I first sort of became aware of serverless about when JeffConf, a little tiny serverless conference, happened in London last year. And afterwards I was mostly amazed at how amazed people were, because I had seen serverless for a few years already. I worked at Amazon. I had access to Lambda in its early days, and then of course, you know, when you work at AWS, they're happy for you to use things like Lambda. So it didn't have the usual sort of friction that you might see with integrating serverless into solutions. So for me, it was sort of a somewhat established thing, and it wasn't really so fanciful to me. And I thought, you know, there's a lot of confusion here over something that's actually quite simple. So I proposed that you could build a simple proof of concept serverless framework on stage. And this guy, Paul Johnston, who originally started the JeffConf series, and he now works at AWS, he told me to do it because he agreed. He agreed that some people were kind of overthinking it. So I came up with the idea of something called Scrappy Surrealists. If you don't know the word Scrappy in English, it's something that perhaps is capable of a lot more than you might originally think. 100 lines of code really isn't all that much, and it might sound weird to implement serverless and something like that, so Scrappy. Yeah, and it's not intended for you to deploy code on it, so please don't do that. This only exists for educational purposes. So the general workflow that you want to present, so we've sort of presented this workflow before, where, as we often find out when we go through school, you learn how to write a program, and it's like, great, how do I actually run this anywhere other than from my IDE? And usually it's about another 3 or 4 years before they figure out how to do that. And the goal ultimately with serverless is to simplify the deployment mechanisms that happen after somebody has code written for a function. So it's a little bit, in a way, it's like rethinking CI/CD or taking CI/CD to a very, very deep extreme. Yeah. And it's, in a way, it's sort of combining your build system with your deployment system, with your runtime system, and abstracting it all completely away from the developer. So ultimately, what we want is for the user to send some code up to a framework. In this case, it'll be Scrappy Surrealists. In real life, it's Lambda or something like that. Some type of image based on that code gets built somewhere. And in some cases, the user wants to build the image themselves locally and push the image instead of the code, and you can do that also. Or you see combinations of that where you like there's people show ways to sort of build a Go binary or Bash script and have Lambda execute that by wrapping it with a little bit of JavaScript and putting it in a zip file. But in this case, we're going to take the code and we're going to compile it on the serverless framework itself into an image. That image is going to be executable by some type of dynamic infrastructure, which comes up whenever we get a call received for that particular function that was submitted. And we need to have some way to route the result of that call back to the user from that sort of invisible dynamic framework back there. Yeah, and so that's the basic process that we want to go through. So I'll get started with writing some code. So we're going to create a way for the users to just submit some code into the framework at this point. So I guess you guys are able to see this just fine. So what I have right now is a basic web server. It's just really a hello world web server that also has a Redis connection object in it. So I can show you what it does now. It just reports that it has a Redis connection. And on the index, we just get a hello world message. So we're going to add a new method to this that allows us to submit the code. Okay, so this we're just adding a new method here. It's going to take a post method for it, and we're just going to test that to make sure that works okay. Oh, this is much too small to see. Can you see that okay, or do you want that a bit bigger? Okay. Okay, so there is now something responding when we do a post. But what we really want to do, for one, is have a new line ending there. What we really want to do is be able to send some code to it. So I have this famous algorithm here, hello world, and what we want to be able to do is send that code to the web server and have it automatically host it for us. So ideally it would look something like this. We just use -f in curl to sort of set it as a form value, but right now it doesn't do anything with that. So see here. Let's take the code and save it somewhere. So it looks like we're saving the code into /temp now, and we can confirm that the code's being received by having it just print out the code that it got instead of hello. Maybe. Unused argument fn. So I use pylint, which is a Python lint checker. It's rather picky, and it's a way to make sure I embarrass myself up here in a very particular way. So yeah, we can see that the server actually can see the code now, and it should be saved in disk there. So I'm going to move on to this sort of next step of taking the code and actually generating an image, because we could take all of the code and just keep it, in string form, but that doesn't really make much sense. The user doesn't want to wait till runtime to find out that there's some problem with the code. So I'm going to use Docker to do this. Have you guys written Docker files? Okay. So I'm writing something called a Docker file, which is sort of a recipe for building containers. Yeah, some of it may not make sense, but that's okay. So we want to get a directory for this specifically. So I'm going to make a directory called /worker in the image, and put the handler.py that we got, which is the code the user submitted, into the worker directory. And then I'm going to use something called RQ, which is a queuing system based on Redis. It's basically a simple RPC mechanism that works over Redis and is really convenient to use in Python. And that takes as an argument the queue that you want to operate on. And so I'm going to use the function, the name of the function in this case, as the queue name. So we're calling the function hello, and so the queue will be hello. And we need to do a Docker build. And we'll capture the output of the Docker build. Okay, so let's try that again. Yeah, so we got a Docker build. Let me actually put this out in a slightly different way, so it's a bit more clear what's happening. Yeah, so if you've run Docker builds, this should look very familiar. The build did successfully go, and we have this image name that comes out in this last line, successfully built, blah. And we can actually run a command in there, and we can see that the image does start out in the /worker directory, and there is a handler.py file there, which is the code that we submitted. And let's see, not everybody here is super familiar with it. So if we do a Docker PS, actually the whole system itself is running in Docker. So you can see the UWSGI, that's the the Scrappy Serverless image, that's the framework itself that we're running. We have a Redis server as well, which is something that just the queue needs as a dependency. And then we have this image that we just built. So this is the one that I'm just running interactively here. So we'll leave that image. Actually, there's one more thing I want to do. So might be interesting to run it without the entry point set. Okay, so name doesn't resolve. Okay, so we can see that it does, when we run it on the right network, correctly connect to Redis, and it looks at the queue, but there's nothing on the queue. So that's fine. That makes sense. So we seem to be here now. We have a properly built image. But now we need to take calls against hello and actually instantiate this image into some type of infrastructure. So I just did that manually. It needs to happen automatically when we get calls. Oh, I missed a step. We'll come back to that. So we have the image that's built here, but we need to capture this ID because we're going to need to know which image to call later on. So I'll make, at the top level, just a map of the images. So we'll look for that last line that we care about. So grab the last word there, which is the image name. Oh, there's an error. FN is unused. Oh. Okay, so we captured the image ID this time, and we saved it in the map by the function name. So now we can implement something that actually takes that image and executes it when a call is coming in. We weren't going to get very far without that before. So we'll instantiate a queue item to connect to the Redis queue within Python. Maybe. So I missed the argument there where I had to set the Redis connection. I didn't know how to speak to Redis. Okay, so now when we make a call, it's able to speak to Redis, which is good. We need to now grab the image ID. And we're going to start a Docker run call, kind of like I did manually. So it's going to be another sub-process. Is that everything? And then the image name. And yes. Call this job. So we'll send the code again. I have to send the code back because every time I change the code, there's this piece that automatically does Docker compose down and Docker compose up. So Redis has gone away and it's an in-memory database. So basically all the data is destroyed every time I hit save in the editor. Okay, so we got hello serverless back, which is actually getting, so we're actually getting the result out of the function itself. So we've been able to implement something where the code gets submitted to the framework. We built an image, which is the Docker image ID that we got. We bring up some temporary infrastructure, which is just Docker run. It's about the simplest temporary infrastructure you can get these days. And we routed a result back to the user. It's a bit boring as a function, though, because it doesn't take any arguments. And it turns out most functions in the world have arguments. So we're going to modify this a bit. So now it will take a name parameter, but it will default to something. So we can submit the code again. None. Not very good. What's that all about?
You'll have to say name instead of user.
Yes, thank you. So there was when it would have it wouldn't have even come up to have a response, which is why there was no response. The response was done. There was probably some error on the left that I didn't notice. Yep. So, yeah, we're getting a response back, but we're not able to pass the parameter in. It's just using the default one right now. I'll add a new line there because that's annoying me. So we're going to build up something called quargs in Python. It's basically just a dictionary of parameters. We're going to pass parameters by HTTP, which allows multiple values for each one. And this is condensing that list down, so we take just one value for each thing. So there can only be one name. A name will not be an array. So we can call it, and maybe we can pass a name in also. that's it. And it's not very big. It's not only less than 100 lines, it's less than 75. So what's the takeaway from this? The takeaway from this is not that you should go build your own serverless framework because it's so easy and there's nothing to it. The takeaway from this is that you should not think of serverless as something that's exotic and totally different from what you've done before. We wrote code, we submitted it to a system, and much like any other CI/CD system, it automatically built it and automatically deployed it for us. It just so happens that in this case, the deployable unit was a function itself. In the end, we don't have a whole program running somewhere. We have just one function, which could become part of a program later on. And then networks, under this kind of thinking, networks change. Networks used to be a series of computers that all talked to one another, and then it kind of went to a higher level where it became a set of containers that were all talking to each other, or VMs. So you have the network sort of grew inside of the machine. And now the network is sort of growing in a different direction with serverless, where you end up with a network of functions that are all able to communicate with each other. So it's also, in a way, about really abstracting the networking away. I remember, like, when I first started doing programming, I could write all kinds of programs locally on my machine, and then Unix sockets. I think I put off for 3 years learning how to do Unix sockets, because integrating networking into an application in the late 90s was like, it was a serious undertaking. And now it's absolutely nothing. So what? So it's going to be network enabled. And that's, I think that combined with sort of like the CI/CD and the changes to deployment is what serverless is really all about, along with the financial things. But I'm not really in finance, so I can't speak in depth to what that actually means. But if you enjoy the idea that you could implement serverless using just any old Docker host, there is a project that is production ready, for the adventurous anyways, Open FaaS. And this is getting used in the real world. And if you want to introduce serverless sort of on-prem without jumping into AWS or something like that, or being able to do small experiments, Open FaaS is a nice way to sort of get started with serverless. And it works a lot like what I just built does, and so does Function. They just go by FN. Yeah. So I'm Bearded Foo. Thank you for thank you for coming, and I hope you enjoyed it. Any questions?
Well, not really about this demonstration you did, but in general, when you upload a function to a serverless platform, I was wondering how it works with dependencies, like for instance in C#, when you do something with JSON, when you do it in the old, let's say old-fashioned way, but how we do it today, then the Newton-Joft JSON library will be packed together with the executable. So in a function, when you use a JSON function, then you are dependent on an external DLL. How does that work when you upload such a function to an Azure function or?
Yeah, that depends on how flexible the interface is. So you can see in this case, this framework I just built is really inflexible. You have to upload only one file, and it has to be written in Python. And nothing else will work in this system. And of course, maybe you could expand this to support other languages or something, but probably this would end up being restrictive anyways because you're only taking one file. So different. That's one reason I like this talk, is because it kind of brings up the right question. It makes you think about the decisions that the vendors are having to make when they build a system like this, and it makes you think about what the right decisions are. So I think it depends. A lot of people would want something so flexible like that, where you could really upload a full binary to it, and you can execute the binary inside of the system. Lambda is able to do that because you upload a zip file to it. And actually, if you look up documentation online, you can find out the underlying systems, and you can even send native binaries in the zip files and execute those. Whereas exactly, so it's
self-contained packages, I think.
Yeah, it's one way to think about that sort of deployment is like containers. But now instead of putting the whole program in a container, you're just putting one function in a container, which does bring some interesting options now. Before, if you have two sort of very different pieces of an application, you would have to make an architectural decision. Do we build both of these in the same language? What kind of RPC libraries are there between them? Can they share dependencies? And often you make a trade-off where you select dependencies on account of one part of the application that actually makes another part of the application a lot harder to write. And then you're faced with this challenging architectural question of, okay, so do we now have to split these and start doing microservices or something like that? And in a way, microservices then sort of becomes this practice of deciding which functions should be grouped tightly together and which ones should be coupled by the network instead. And I guess serverless is just a way of saying, yeah, forget all that, make them all separate anyways, and then you don't have to worry about those things. So it's going to be different for everybody. Everybody's going to, right now at least, have a different philosophy on what should be the thing you upload. Some people think it's okay to upload native binaries into Lambda and call them. Some people think you're sort of kind of hacking the system and it's not such a good idea and you should really just upload a zip file with some code in it. And actually, even in serverless, that zip file, it's probably not going to be just one individual function. It's more of one function from your API perspective. But some people are thinking that maybe HTTP should be essentially the new function calling convention rather than using the old C calling conventions or whatever else. So it's a bit of a debate right now, I think. What you're asking is possible, but it's a bit of debate as to whether or not that's the right way to use this technology. And I don't think there's any clear answers on it yet, which is probably why there's still serverless forums with only a couple people showing up. Because it's all a little bit fluffy right now. There's some real systems, but I think, for instance, I think Lambda, if you look at it now, it's very different than what it was a few years ago, and I think in a few years it's going to be very different as well. It's going to keep changing. This is not, yeah, serverless is definitely a moving target right now. And the interesting thing is it seems like it could mean anything but getting rid of the servers. It's really just talking about how we're going to use the servers. It's about, I think serverless more so refers to sort of your developer's mind and your architect's mind. It's getting the servers out of their heads. When they go develop something, they don't have to think about servers anymore. They're not drawing a box on a whiteboard that represents a computer anymore. They're able to think at a higher level in terms of just how they want to organize code and let the runtime system sort of figure it out from there. Does that make sense?
Yeah. And it changes the whole idea of how your application is architected. Because when I think of the application we are maintaining, it's a monolith and it consists of thousands of functions. So if you would upload all those functions separately to a serverless platform, that would be a mess.
It could be, yeah, especially if it's not presented in a manageable way. How do you even view it? Can you get an idea of the state of it and how they all connect? It's a big question. On the other hand, when you look at compiling these big monolithic applications with so many functions all entangled, that's its own mess. It's just a mess that we've sort of become comfortable with, or perhaps we've become complacent with. And there's a lot of ways that can go wrong as well. And there is a lot of freedom that developers can have just by getting the idea of how to build one particular function for your API, and they can go off and develop that without having to get sort of entangled with the rest of your API. But then there's probably some kind of interpersonal challenges that might come from such freedom. A lot of kind of, I guess, compliance questions. Is everybody really going to be just using whatever dependencies they want? We don't want every function of the API written in a different programming language or whatever programming language that engineer was excited about that week. So I think it adds a lot of compliance questions as well. There's a lot of sort of fields of this that haven't quite been explored.